Today we discuss the function and image set and pre-image set. Image set, here let f a to b be a function. If a0 subset of a, then f of a0 the set of all images. The set of all images of a0 under the function f. The set is called the set of all images of a0 under f is a set of all points a0 under the function f is called the image of a0 is called the image of a0 is called the image of a0 under f. Then this one is denoted by f of a0. F of a0 equal to b such that b equal to fa for at least a belongs to a0. And if b0 subset of b, then f inverse b0 the set of all points elements of a whose images under f lie in b0, which images is in b0 under f is called the pre-image of b0 under f. Okay, and this denoted by f inverse b0 equal to those a such that fa belongs to b0. Okay, those a such that fa belongs to b0. Now we erase this above portion because we know about that image set and pre-image set, so we erase all these portions. Now we discuss important topics. At first we give some example of image set and pre-image set. Okay, simple example we take in, then understanding is more better. We first take the simple example 1 2 3 4. Here we take a b c d e f. Okay, this one a, this one b, this one a0, just 1 2, and here this one b0. Okay, here f defined. Now f of a0 equal to 1 to a, 2 to b, in this way defined. Then f of a0 equal to ab, and f inverse b0 equal to also 1 2. Okay, if here c going to 3, then 1 to 3, but c is not related to this, then f inverse b0 equal to just 1 2. Now this one is the image of a0, this one is the pre-image set of b0. Okay, now we discuss one important property which are typical and not understandable for common ones, and all are called a dangerous problem, which is one simple problem in mathematics. A subset of f inverse fa. How we handle it? We first see it in this way. Here a, we talk a, not a, we talk, if we talk a, then here x, but we here talk just a0 and then this one fa0. This one is a, this one is a0, this portion. Okay, and this one is B, and this portion is FA0. Now here some C0 subset of A, and A0 also subset of A. Then f of A0 equal to f of C0. Okay, in this way, that means f of C0 equal to this one. Then we see some interesting property. That means f inverse of f of A0 equal to how much? C0. This one equal to C0. That means A0 subset of this. A0 subset of this. Okay, so we proved in this way. And if f is injective, then A0 equal to f inverse f of A0. Okay, if injective, then this one is done. If injective, then A0, just A0 is image set is FA0, not C0 have image set f of A0. This one is not possible. That means just one element going to another one. Here we construct 1 2 3. Here we construct A B C 4 D E, then 1 this, 2 this, 3 obviously this. Okay, then A0 have f of A0, ABC, and f of C0. We write this one. Okay, f of C0, here CD, here we write CD. Then f of C0 have also f of C0 have equal to f of A0, but this is not possible for this case if f is injective. If f is injective, then this one is not happen, and then we get just A0 equal to f inverse of f of A0. Now we give some example we created here, but now talk about more and interesting way. We see this one is A 1 2 3 A0 4 5, here C0, here A B C D E F, A B C 1 2 3 done. 4 is C, f of A0 this one equal to f of C0 this one is B. Okay, this one A, and f inverse of f of A0 equal to f inverse of f of A0 equal to C0 equal to 1 2 3 4, and f of A0 equal to ABC, and f of C0 equal to obviously ABC, where A0 equal to 1 2 3 and C0 equal to 1 2 3 4. Okay, then we see that A0 subset of f inverse of f of A0, and if injective, then this equality holds. Now we proved this portion. Okay, now we do done another important inequality, which one create more obstacle in our path, and we can't handle this easily, but we see it, then this one is an easy problem. Okay, which problem is this? F of F inverse A B0 subset of B0. This one is A0 A, this one is B, this one is B0, this one is A0, and here obviously we don't donate, this one is not needed here, this one is F of A0. Okay, then this one F, that means F inverse B0, F inverse B0 equal to B0, F inverse B0 equal to what? F inverse B0 equal to here A0. Okay, and F of F inverse B0 equal to F of A0 subset of B0. Okay, in this way so we get it, F inverse B0 is A0, that means F A0 going to F of A0 is the image set. Okay, but pre-image of B0 obviously here A0. In this figure we write it by simple example, we write it or we see it simple example, and here equality hold. When equality hold if F is surjective, that means onto. If F is onto, then this equality is hold. Then how we write? That means we check it by simple example. Here 1 2 3 A, and this one A0, and here A B C D E B, then A B C equal to B0, and A equal to F of A0, that means just this one. Then what happened? We write it A0 equal to 1 2, B0 equal to ABC, and F of A0 equal to A. Then F inverse B0 equal to A0. So F of F inverse A0 B0 equal to F of A0 equal to A subset of B0. So in this way we handle some example, and we understand better, or we understand properly. So today here we also known that A0 subset of F inverse F of A0, and F of F inverse B0 subset of B0, and image set and pre-image set. Now we're going to discuss about one simple example which is familiar of all. I think we're going to this example to understand better or clearly this portion. we erase completely. Now we want to further progress. We're going to some example, give some example. Okay, just if R2 are given by fx equal to 3x square plus 2, then AB is the closed interval, and now we draw this figure. 3x square by 2, here -1, here 1, here 2, here -2, here 0, and we discuss this figure. Here 1, here 1, here 2. We discuss this figure more logically. Okay, in 1 this one is, in 0 this one is 2, in 1 3 to 5, and -1 obviously 5. Okay, so here f inverse of closed interval 0 1, f of closed interval 0 1 equal to how much? F inverse of f of 0 1, f0, if we put here 0, then this one is 2. If we put it 1, then this one is 5. That means f inverse of 2 5, f inverse of 2 5, f inverse of here 5, 2 5 equal to how much? Equal to -1 1. Okay, f inverse of 2 5 equal to -1 1, and f inverse of 0 5, f inverse of 0 5 equal to how much? F inverse of 0 5 equal to -1 to 1. Okay, f inverse of 0 5 equal to -1 to 1, and f of -1 to 1 equal to 2 5. Okay, so we understand this problem. F inverse of 0 1 equal to f inverse of 2 5, here 2, here this one 2, f of 0 1 equal to 2 5, and f inverse of 2 5 equal to -1 1, and f inverse of 0 to 5 equal to 2 to 5 equal to -1 1, and 0 to 5 equal to obviously -1 1, and f of -1 to 1 equal to just 2 5. So today stop now.